Good morning, good afternoon, and good evening, everyone, and welcome. Today, the Project Production Institute is hosting its second virtual conference about supply chain resiliency during COVID-19 and beyond. Thanks for being here. We're glad you could join us for this hour-long conversation with our panelists. My name is Paul Masai. I'm the Executive Vice President for Oil and Gas at Strategic Project Solutions, and I will be moderating this panel. As you know, the global pandemic highlighted supply chain vulnerabilities and critical shortcomings. The current upheaval in supply chain has raised several questions related to capital projects, such as how resilient are the supply chains for capital projects? Are global and local sourcing the answer? Can local content goals be achieved in this environment? Given the many questions, what can and should project professionals do to minimize the impact of supply chain disruptions on their projects? Let me start with a personal reflection. Throughout my career, we used, among other things, inventory as a buffer, or if you will, a defense, to mitigate disruptions or to accelerate project schedules. The practice did not achieve either, and in a majority of cases, projects actually ended up costing too much and taking too long. Gary Fisher and I co-authored a paper on this topic, which is the basis for today's web conference. PPI invited leading supply chain science experts and practitioners to discuss how effectively to optimize and control supply chains for capital projects. Before we introduce our speakers, a quick logistics note. This will be an interactive session, so please post your questions throughout the panel presentation using the question dialog box. We will take time at the end of the hour to answer as many questions as we can. In addition, we'd like to announce that PPI's next virtual conference topic in our series will be on how to get COVID-19 pharmaceuticals to market faster, a very timely topic and a critical topic that's affecting the globe, as you all know. This will be held in September, so please be on the lookout for the invitation, which will be out soon. So now, let's introduce our panelists. It's my pleasure to introduce Gary Fisher, who is the chair of PPI Energy Working Group. He recently retired from Chevron after spending 41 years working in all aspects of major capital projects in downstream, chemicals, upstream, both domestic and international. He was the architect of Chevron's project management system and led an organization that provided project functional expertise across Chevron's global portfolio. Gary holds a Bachelor of Science degree in civil engineering from Colorado State University. It is also my pleasure to introduce Phil Kaminski. Phil is a professor at UC Berkeley in the science and analysis of decision-making in the Department of Industrial Engineering and Operations Research. He is currently on industrial leave at Amazon as a principal research scientist. Phil's research focuses primarily on the analysis and development of robust and efficient tools and techniques for design, operation, and risk management in logistics systems and supply chains. Phil received his bachelor's in chemical engineering from Columbia University and his master's and PhD in industrial engineering and management science from Northwestern University. Last but not least, it's my great pleasure to introduce Mark Spearman. He is the director of the PPI Technical Committee and the technical director at SPS. Prior to his role at Strategic Project Solutions, Mark was the co-founder and CEO of Factory Physics, Inc. During the past 30 years, he has improved operations and increased profits at over 100 companies through the application of operations science. He is a co-author of Factory Physics and Factory Physics for Managers, along with numerous other papers. Mark holds a PhD in industrial engineering from Texas A&M University. Welcome to all our panelists, and thank you for being here. To start our conversation, let's level set the definition of supply chain. According to Wallace Hopp, a supply chain is a goal-oriented network of processes and stock points used to deliver goods and services to the customers. In this instance, for this discussion, the customer is the project. So Gary, based on this definition, let's start with you. As a project professional, what do you think about the definition, and what does a resilient supply chain for projects mean?
Thanks, Paul. First off, I think that definition requires a little bit of translation for a project guy. And from my point of view, I'd keep it pretty simple. It's all the activity involved in sourcing and delivering materials, equipment and materials to the point of need. I could argue that engineering and in some cases labor could even fall into that definition, but for the purposes of the paper that we authored, we're really focused on the equipment and materials. So what does a resilient supply chain for a project mean? That's a great question, and I think that's really part of the problem, and that's why we have this conversation. It's why we wrote the paper. Is we have a whole bunch of different opinions on what the answer to that question. And it's really, the answer would be dependent on the person's point of view, their experience, and their paradigms. And I'm sure we'd have a lot of them if we could poll the audience on that. To net it out, though, I think the natural reaction, I'll say my natural reaction before my understanding of operations science grew is totally different than it is today. So today, I would say a resilient project supply chain has three major characteristics. One, it's simple as possible, it's short as practical, and it's flexible. And of course, we're going to talk about these kind of issues through the webinar here.
Thank you, Gary. Mark, you have an interesting observation. Tell us about the relationship between the likelihood of a supply chain interruption and the consequences of the interruption.
Well, what I've seen is a lot of companies make two mistakes in trying to protect their supply chain. First, for ordinary fluctuations, they keep too much inventory, or they set too long a production procurement lead time, which effectively does the same thing. What they'll do is they might need, say, 24 days of safety stock, but just for good measure, they'll add it to another 24 and have 48 days, or maybe even 60 days. Whereas the 24 days got them about 100% probability of getting stuff shipped on time under ordinary conditions. So that's where on this slide here we talk about buffering flexibility. Those are the ordinary conditions when you have fluctuations in demand and fluctuations in supply. But they'll add this extra inventory or lead time to just in case. And then that turns out to not be enough to avoid a situation like COVID, some 9/11 or COVID-19 or something like that. Is not going to be buffered by that inventory, and really shouldn't try to buffer by inventory. When you get something like that, for those kind of events, you need a different kind of buffer, something like having another source to call upon, some extra capacity that you can bring in, maybe local suppliers, something like that. And when you're in that situation, you're looking at, doing something different, like having some planning for different contingencies, and even an emergency response, which could be you've got agreements with other partners to come in and help on those kind of situations. But for large disruptions, you're going to have more vigorous responses. And I think my friend and colleague Phil has some ideas about that.
Mark, thank you. Before we move to Phil, I guess just to maybe put it in project practices today, and this practice has been pervasive throughout at least my career, where contractors buy as much inventory as possible and pile it up on a project website. The old saying, I'd rather be looking at it than looking for it. And that practice has proven to have many shortcomings. The projects continue to incur costs and schedule overruns. So truly, in terms of buffering, the project professional use inventory to buffer and defense against schedule by piling it up and spending unnecessary and unproductive capital and inventory. So thanks again, Mark. We appreciate it. Phil, let's move on to you. Given what we just heard from Gary and Mark, the question for you is, if I am a project professional, why is it important for me to understand how my supply chain should behave?
Thanks, Paul. Well, I think Gary and Mark have made it clear that the effective operation of the supply chain is essential for delivering projects on time and on budget. And so you have to know how the supply chain should behave so that you can design the supply chain to behave in that way. So I think that sort of the deeper question is, how should the supply chain behave? And to me, the key to thinking about how your supply chain should behave is one simple question. Imagine that you owned the entire thing. You had a completely vertically integrated supply chain from the smallest component to the final project. You should ask yourself, how would you manage that? Where would you keep the inventory? When would you make decisions to produce subcomponents? When would you deliver things? How would you pack things together on trucks to deliver them? How would you think about the timing of these events? Where would you manufacture components? And then, so if you own this entire supply chain, it's pretty clear this is your company. You would make deliberate, intentional, carefully planned decisions using all of the available data to operate your business. Why? Because you know how to manage the cost and you know how to manage the risk in your business. And so your goal in managing the supply chain, or to get to put it the way you put it, how your supply chain should behave is, your supply chain should behave exactly the same way as it would if you owned the whole thing. And so when you think about how you design your supply chain, what you want to do is design agreements. You want to have relationships with your suppliers. You want to think about how you place orders and when you have inventory delivered and how you transport things. You want to think about all these things, structure the supply chain as much as possible so that even though it's a decentralized system where there's lots of different owners of big companies and small companies and transportation companies and engineers and the whole set of people and places and machines and things that ultimately delivers your project, you want to design the system so that as much as possible it acts as if you own the whole thing. And I think this is true both when Mark showed you this picture, this is true both of kind of the way that you divide design the supply chain to manage day-to-day variation, where you manage inventory in your supply chain. You think about time buffers and inventory buffers, but also the way that you ensure that your supply chain is robust and resilient to major disruptions, the 9/11 and COVID examples, the black swans we call them, the ones you can't calculate and determine the exact inventory levels for. So in the same way that if you own the business, the entire business, you might think about putting manufacturing plants in 2 different places. You might think of having multiple transportation companies that you work with. You might think of getting all of your managers of all of your far-flung operations together regularly so that they have a tight relationship and can quickly sense and adapt when the system demands immediate reaction. So you can account for all of the variables throughout your system. If you think about, that guideline, how would you manage the system both due to when you have regular disruptions and when you have significant unexpected disruptions? How would you manage it if you own the entire system? I think that's a good guideline to think about the productivity that you should be able to get out of your supply chain.
Thank you, Phil. This is quite interesting. And to put it, to expand a little bit and put it in a project perspective, based on the relationships that you have with suppliers and the long lead items that you have to purchase early to meet engineering requirements or to meet construction requirements. All that network because of today's technology, all that network of suppliers, including engineering houses, for example, all can be monitored and modeled and can be optimized to meet what the project's project schedule requirements are, because technology today allows us to do that. Would you agree, Phil?
Yeah, I think technology is certainly part of it. We can have awareness of what's going on in the entire network, but I think the structuring of relationships is equally important.
Agreed.
Whether they're informal relationships,
yeah.
Just staying in contact, or formal contract structures that share risk and share reward in this kind of system.
Agreed. Gary, back to you, if I may. We just heard Mark and Phil discuss supply chain interruption and behavior. As a project professional, tell us about or share with us some of the current and historical practices that affect a project outcome.
I can't help but reflect on what Phil just said. I think that was really profound, and wish we would have thought of that to include in our paper, Paul. Get your supply chain to behave like you own the whole thing. That's a mindset that permeates everything. And I think the historical practice does not have that mindset. It has a mindset of, these are balkanized companies that we're working with. They have their own, and they do have their own drivers and priorities and those kind of things, but that's unpenetrable. Those are boxes that you can't touch, you can't get inside of, you can't really understand. You got to kind of guess at. And I think that guessing at and that hands-off point of view really drives a lot of bad things happening, and really piles up onto two things. And I think, aside from that mindset, the two historical practices that I reflect on that I think cause the most damage relative to an effective supply chain is, number one is chasing low cost. We have a belief that if we optimize the cost of sourcing the goods, the materials and equipment, that when you add all that together in a project, you've got a low cost project, or the lowest cost project. And it's not the case. I can think of one specific example where we selected a fabricator, a low cost fabricator in a difficult location for critical modules for a project. And that company struggled and kind of went belly up, and we had to take over that fab yard and manage it. And we completely shot ourselves in the foot. Chasing low cost, we spent billions offsetting that with the secondary impacts on the project because they couldn't deliver. So I just see that over and over, that we bundle things together. Let's get a giant order. We can get a better, save a few pennies here, but we compromise things, increase our risk, increase complexity, often leads to out of sequence delivery, and we don't have that tight control or the relationship of, I own this, this is all mine, all the way back to the raw material almost. And then the other one, I think, and you already mentioned it, Paul, is pile it up. I mean, as a project guy, I want it all piled up. As a construction manager, I wanted to see everything out there in the laydown yard, because I didn't want to have to wait on anything. I wanted to pick and choose everything, and I didn't understand the costs of that. And that pile is work in process. Work in process means, go back and read the paper if you haven't read it. Liz Law says the project's going to take longer and cost more. That pile means I have more safety risks because I'm going to end up moving that stuff around multiple times. I can give you example after example after example where we've done that. Damage, obsolescence, design overtakes. We find a design issue and we find we need to make a change in the design, but we already have a pile of the old stuff out there. Well, now we got to buy new stuff and get rid of the old stuff. And then really important is it ties up cash, unnecessarily ties up cash. That cash in a big company or even a smaller company can be used to fund other projects and other things at the same time. So that cash flow is important to the bottom line of and the financial performance of every company. So those would be, and the third thing, that mindset, chasing low cost and pile it up.
Very good. Thank you, Gary. Appreciate that. At this point, I'd like to take a minute just to remind our audience to post your questions on the right panel of your screen by clicking the arrow to open the dialog box and write your questions. As I mentioned, we're going to take as much time as we can and answer as many questions as we can toward the end. I'd like to pose two open questions to the panelists, if I may. And given existing science and the advances in technology, what should project leader do differently than what we're doing today, in addition to the practices during and post the pandemic, to improve their project outcomes? Any thoughts come to mind? Why don't we start with you, Phil, if you don't mind?
Sure. So I think one thing that we've learned in projects and general in industry is that leaders have to be flexible and adaptive. Because one thing we saw during COVID times is that the kinds of things we planned for when we thought about disruptions were a little bit different than what we thought. And so a great example, I think I mentioned to you earlier, but I'll share with the audience, not necessarily related to projects, but something we saw at Amazon is that we have lots of obviously long truck routes where across country, for example, we have to deliver packages across country. We had planned for trucks not being available. We had planned for roads not being available, but we had never planned for the fact that when you have to be 6 feet, have six feet between drivers, you can only have one in a cab instead of two. And given regulations, this means that trucks couldn't drive continuously. And so now it took twice as long, roughly speaking, to get from one point to another distant point. This wasn't in our contingency planning, but what we had to adapt to was a general mindset of being flexible, of picking up on this problem as quickly as possible, and being able to adapt our supply chain to move deliveries more shorter hauls, for example, but in general to quickly notice challenges and to think out of the box to adapt to them, because you can't always plan for all the kinds of challenges that you'll face.
Indeed. Mark, would you like to add something to it? Would you like to add your own thoughts on this questions, or to this question?
Yeah, just something that Gary said reminded me, like Gary's talking about, everybody's chasing the lowest cost, and they really don't develop a relationship with their supplier. The supplier feels beat up. I've worked on both sides of this. Small companies that are suppliers to big companies, and big companies that have small companies as suppliers. And there's very bad communication that typically goes between the two, and also bad relationships. And so if you beat up your suppliers all the time, then when times get good, and now you need components or parts, and now everybody wants them, you're not always on the top of the list to get them. So when things start going poorly, and you work with your supplier to keep them running, then they're going to remember that when things start going the other way. And so it really is relationships, as Phil was talking about. And also not just getting the lowest cost, and then not thinking that having inventory is going to always help you.
Yeah, indeed. It's interesting you mentioned that, both you and Phil and yourself, Mark, because we are receiving a number of questions around the same topic, and we'll come back to that toward the end. Maybe a final question to the panel, and then we'll move on. Why should, I know we talked around this at a high level, but give me some specific reasons as to why should project professionals pay attention to a capital project supply chain. So we know capital projects start with a concept design or product design, then they go into detailed design, then they go into fabrication, or sorry, they go into fabrication, construction, installation, commissioning, startup. But specifically, if you look at the entire end-to-end supply chain, why should that delivers products, materials, services, and labor to the project, why should project professionals be paying as much attention to that specific part of their project as they do to other aspects of the project? Gary, I'll start with you.
I don't know. To me, that answer is pretty simple, as it has huge impacts on the project performance. You know, what you just listed off was mostly what happens on a project. If you throw engineering in that bucket, that's what a project does. You know, it is a big supply chain to deliver some kind of a facility or something to beneficial use for in the energy industry, you know, producing oil or gas. So to ignore it is just really, you know, negligent. And I think aside from engineering performance, the performance of the supply chain on sourcing, delivering materials and equipment to the point of need is probably one of the top 3 things that impact cost and schedule of the project, and have done so negatively, you know, increased project costs because of the practices that we've already talked about.
Yeah.
All based on historical experience, the desire to buffer yourself from everything and everybody by piling it up, ordered early. Am I really worried that the response to the, if you will, the COVID response, the COVID lesson learned will be, I got to do it even sooner. I need more stuff. I need bigger piles. I needed them earlier. I want more. I got bigger buffers. That's clearly the answer, right?
Exactly.
And I think that, you know, anybody that tries that is going to find out, no, that wasn't the answer. You just increased even further, made your problem worse.
Yeah.
More cost, longer schedules. And I think, so, you know, if you're kind of low on the understanding of operation science and project production management, I've been thinking about, well, what could a project guy do right now today?
Yeah.
And I think, you know, our paper was targeted doing that. Also, some of those recommendations require that basic understanding. But I think there are 3 things any project person can do with no understanding of operation science. And number 1 is try to simplify your designs. Don't have something made special if something ordinary will do. And, you know, the example we used in our paper was a project, instead of having designed anchor bolts, they just bought a pile of threaded rod, few standard sizes, designed the foundations to use that threaded rod for anchor bolts, cut them to length at site. Man, that was slick. We weren't waiting on anchor bolts. That's a simple example, but think about that a zillion times across the project. So many things are uniquely designed. Of course, engineers like to design uniquely. They think if they optimize the components, we optimize the overall. And that's not true. We sub-optimize the overall. So that's something any project person can do today. Number 2 is fab as close to the point of need as possible. I've seen us source pipe spools, let me use that as my example, from all over the world with very complex transportation routes to get them to the job site. So we had to first buy the raw material, ship them to the fabricator in some cases, have the pipe spools fabricated, and then transport them to the job site. That logistics chain was long and complex. Took a lot of time, tied up a lot of cash. I'm advocating do it right at your job site or as close to as possible. Huge impact on local content. You know, you can run a fab shop right at the site based on demand. Give me 3 days demand. What spools do I need in 3 days? I'll guarantee I'll have those spools fabricated 3 days in advance, something like that. And then lastly is know your suppliers. We got to stop looking at them as a black box, something unpenetrable. And if I really like what Phil said, if you own that company, what would you be doing with that capability? How would you be working with that organization differently? Approach it with that mindset, especially your key suppliers. You should be right there, right up in their grill. You should be working on your production schedules together. You ought to understand how your own as owner or contractor work steps interface with that supplier's work steps, so it all flows seamlessly. It's optimized for the production of what you need. And, you know, those 3 things anybody can do. There's nothing to keep you from doing it.
Thank you, Gary. Very, 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 very interesting and timely indeed. So I'm gonna start switching gears a little bit to we've gotten a lot of questions, and so I'm gonna try to combine a few questions to the panelists. The first question comes from a very beautiful country in the Arabian Gulf called Qatar, and the question is twofold. The first question is, this gentleman asks, we have been instructed by our senior management to go after our contractors and suppliers, to your point earlier, Mark, to ask for discounts. As a matter of fact, we are pushing our contractors to give us massive discounts on existing agreements that we have, part A of the question. And part B of the question is the concept of just in time. Is it still relevant in a COVID-19 world and beyond? So why don't we start with Mark on a discounts question, and then we'll do the just-in-time part with Phil. Mark, over to you. How do you feel about beating the suppliers for additional discounts?
Well, as I mentioned, that can be counterproductive if you have an antagonistic relationship with your supplier and things go south. You're not going to be the one to benefit from it. And if I could just say something about the just-in-time, to Gary's point, when you look at where just-in-time came from, it was developed in the Toyota production system. And Toyota had basically sort of a feudal relationship with their suppliers, and their suppliers are always very close. And Japan's not that big of a country. And consequently, they were always, very close to each other, and so just-in-time made sense. When you're using an Asian supplier and you're talking about just-in-time, then basically what you're going to get is a middleman who will carry the inventory so that you don't have it, so it comes in just-in-time. I've seen so many plants that talk about, brag about, well, we've got half a day's worth of inventory in this place, and there's this huge warehouse outside, and you ask about that, and they say, oh, that belongs to our supplier. Well, if it belongs to your supplier and you're the one who's using it, you're paying for it. So all that carrying costs and everything, it's built in, so you're not really changing anything. So how you set up your relationships, both logistically, geographically, and everything, they all have to make sense, and people need to understand when to use a time buffer, when to use an inventory buffer, when to use extra capacity, and so on.
Well, thank you, Mark. Since you answered the just-in-time question, Phil, I have a similar question to you.
I can answer for that one.
Yeah, he saved you, I think.
Okay.
I was waiting for it.
But seriously, another question is, planning for black swans seems to be a good thing to reflect onto it deeply. But how do you plan for the unknowns, i.e. COVID-19, which was not predicted by anyone 12 months ago? And if you don't mind, Phil, for the sake of our audience, please define a black swan event and then move on to the question. Thanks very much.
Okay, so when I say a black swan event, what I mean is an event that you can't predict the likelihood that it's going to happen, and happens frequently enough that you can maybe have a little bit of extra inventory to hedge against this kind of risk. It's a sort of unpredictable and deeply impactful event. This was the events that I think the lower right of Mark's diagram, if I recall that diagram correctly. And so, look, there's only a couple ways that you can deal with these kind of unknown unknowns, the sorts of events where you can't even predict the exact nature of the events, right? One is to build flexibility into your supply chain, right? So perhaps you have relationships with different suppliers who can, and they can manufacture different things. If a particular plant goes out, perhaps another supplier can supply that part. So you can build a flexible supply chain. You can build redundancy into your supply chain so that you can you have alternate ways of managing the particular challenge that you face. And the other thing you can do is you can build a capability to understand that there's a problem before other people do. Because the faster that you understand that there's a problem, the faster that you sense, you know, not just that COVID-19 is happening, but how that, for example, impacts the transportation to your job site. The faster you know about the impact of these events, the faster you can react to them. And so flexibility, redundancy, and effective sensing and responding mechanisms are really the ways that you can deal with these events, as opposed to day-to-day variation, sort of known unknowns that you can deal with the kinds of buffers that Mark spoke about.
Thank you, Phil, very, very much. There seems to be a number of questions coming through around, quote unquote, a trend by owners and operators asking fabricators, contractors, engineering houses for discount. And this trend seems to be increasing rapidly during this pandemic. And the question is, what is the panel observations as far as this trend and its long-term effects? I think, Mark, you answered part of the question. I'd like to share an observation and then open it up for the panel, and we'll start with you, Gary. My observation is quite simple. It has always been, if I may, the easy route to blame the contractor and the suppliers when project goes sideways. We did not reflect on ourselves as owners and operators as what we could have done differently. The road to asking contractors and suppliers leads to a number of things, but one major thing: you're gonna run them out of business eventually, where they cannot provide the support that you need in the quality that you needed in the time that you require. So this is a very slippery slope that owners and operators are advancing on. And by way of example, a major IOC recently announced publicly to the world that they will not, I repeat, they will not be asking suppliers and contractors for discount, because this is not the way to build long and cohesive relationships. Rather, they're going to work hand in glove with their suppliers and contractors to figure out how do they jointly optimize and take costs out of the supply chain, to collectively, not us asking you for discount and you're doing our bidding. So back to the trend, Phil and Mark and Gary, have you observed this? And if you have, what are your observations for the long-term effects?
This trend is nothing new. This isn't a new trend. I can think of the 4 or 5 really dips in the price of oil and gas, and this happened every time. That's a natural reaction. Oh, go back to the suppliers. Let's negotiate discounts. Let's go beat them up. Let's have them share the pain. Looking back and reflection, I don't think that helped us at all. It didn't reduce our project costs, total cost. And I understand why company leaders want to do that. I mean, they want to reduce their total cost of, completing a project. And I totally understand that. But I think it's born in a misunderstanding of what constitutes the total project cost. What we're talking about here are the direct costs, the actual costs of goods and services. But the total cost, you got to layer out all the indirect costs, all the other things that we do that are needed to make that work. And indirect costs are staggering. If you expose them and truly understand them, they're staggering. And yet this decision, this drive to drive down the direct costs, my observation is almost always increased indirect costs. We created ourselves quality problems. We created ourselves delivery problems. We created ourselves priority problems with those suppliers, because if they're making, or if they're losing money doing business with you, do you think you're going to be at the top of the list on delivering stuff? Absolutely not. I just, nothing good that I saw, and this is the historical experience, and today's experience is not going to be any different. It's not going to turn out any differently. And instead, I think it's far more productive and useful to attack this need to lower total project costs in a completely different way. And that completely different way is born in operation, harnessing, understanding operation science, applying project production management, developing the right kind of relationship with your suppliers, and be able to, it takes you to a whole nother area and world of how to truly lower your costs of doing business. And it's not dependent on this price environment. It can be done anytime. It's just now it hopefully generates the need and the excitement and the emphasis to tackle this problem in a completely different way. And it's possible, and you can see it. And once you've got some experience with it, you go, wow, we really reduced our costs here in just a completely different way. And it's not by taking advantage of the suppliers.
Thank you, Gary. We continue to receive a lot of questions. Phil, this one's for you. I think how does Amazon view the relationships with their supply chain, and are they driving for discounts?
So I think,
yeah,
I can just very generally, I think the key is a focus on thinking about cost and risk. So sharing risk and sharing cost in the supply chain. If we expect a supplier to take on more risk, whether it's volume risk or delivery risk, then they should be paid more. And so I think without going into things, details that I can't go into, I think it's this kind of view of balancing. It's not just cost, but understanding this relationship between cost and risk, and understanding that there's a trade-off between them. It kind of defines the way we think about that question. Well,
thank you. Gary, I'd like to come back to you, and then Mark, I have a question for you toward the end before we start, before we answer further questions. Gary, the question to you is around our projects not executed in the same way, haven't been executed in the same way for the past 10, 20 years, maybe 50 years. If not, what has changed, or what should change in the next 10 years, and how project delivery should adapt when the share of the new energy project will increase?
So I don't think projects have fundamentally been developed and executed differently in the past 40 years, my entire career with Chevron. I mean, we got a little better. We learned some things. It did improve, but historically, and even today's experience, project in the energy sector, large projects in particular, tend to take longer and cost more than expected. And that's just been a perennial problem. And that problem can only be addressed through, again, understanding operations science, applying project production management. And I think that will radically change how projects are developed and executed in the energy sector. And then you layer on top of that technology and the potential for harnessing technology in a completely different way. I mean, we touched on it just really briefly, but having all the stuff that's coming at you tell you where it is and its condition. Having systems that are automated, that are self-correcting and self-healing and self-adjusting, so that we don't, right now we have a massive intervention of people in all the work processes. And we're going to change from people or machines helping people to people helping machines do the work. And there's so much potential out there. I think the project of the future looks way different than the historical practices or the practices today.
Gary, thank you very much. Just before I get to Mark, for the sake of our audience and our listeners, can you define project production management or elaborate a little bit? When you say project production management, what do you mean?
Well, I mean, and Mark can correct me because he wrote the book.
Yeah.
Operation science is the science that governs, dictates how these kinds of processes work, the transformation of raw goods and services into finished products. And you know, in a capital project in the energy sector is no different. It's all driven or governed by the rules or the laws of operation science. And project production management is simply the application of understanding and adapting the work practices to understanding those rules, that science on how projects behave. So one is the science, one is the application.
Thank you, Gary. Mark, would you like to add anything to that? And then I do have a question for you about project production management and operation science and their application on major capital projects.
Yeah, I'd like to add to what Gary said about going after discounts. That the usual way of doing it is to, try to beat up the supplier. The good way to do it is when you're the big company and you're able to develop operation science techniques, PPM techniques, to go to the supplier and teach them those techniques and look at the supplier and see where the savings can be. And I've been in 100 plants, and there's not a plant I've ever been in that, there weren't things that you could do to make things run better. And the other thing is, one of the things Operation Science teaches is there's 3 ways to buffer the variability. It's inventory, everybody knows about that. And if you don't have inventory, it's time, because things are going to be late. The other one is having extra capacity. And that means that if you look at how many man hours you're going to need, you need more than that. And if you have those more than that, then you can catch up when you get behind because of some disruption that you didn't anticipate. And so I think that's one of the biggest things I have seen is people end up being penny wise and pound foolish, because yeah, they're very efficient as far as the labor goes, but then the project's always late. And so it's not so efficient.
Well, thank you very much. We have a question coming in, and I'd like to pose it to panelists, and then you guys decide who would like to start. The question says, are there examples of AI, artificial intelligence use to signal supply chain impacts while it mitigates carrying associated costs with building the flexibility and redundancy? This was a focus of efficiency and for a number of years. So is AI being used today to mitigate any disruptions in the supply chain, reduce carrying costs, reducing the overall supply chain costs, and provide flexibility? Anyone would like to answer, take a shot at that answer?
So one thing I know specifically about, because I work on it, is transportation costs. So this maybe doesn't directly get at the question, but this transportation and certainly in many industries is a big part of supply chain costs. And one thing we do, for example, at Amazon is use AI to understand the direction that the market for line haul transportation is going. And based on our assessment of and forecast of the direction of the market, we understand how to structure contracts to lower costs by sharing risk with our transportation suppliers. So in principle, the same kinds of approaches could certainly be used for any kind of commodity product that you're obtaining, where if you sense that the market is tightening or the market is loosening, you can go to suppliers and you can, for example, pre-purchase. If the market is tightening, you can pre-purchase certain amounts of supplies that gives the supplier enough capital to maybe expand their capacity to make them more reactive. And you can do that by using AI techniques to get a better sense of the direction of these kinds of markets. That's the example that comes to my mind.
Thanks, Phil. Gary alluded earlier to smart production systems. What I think, Gary, if I may, could you elaborate on that? How do project production systems, with the help of AI and IoT and ML and Wi-Fi and other technologies, how are those impacting the resiliency of a project supply chain in your view?
Well, then, in my view, or in experience, they're not impacting it very much because the application is very, very skinny in the energy sector. I think it's more of a potential opportunity for from today forward. Just let me throw out one really simple example. I've got an onshore project. I've got a warehouse of materials. I can envision a world where very simply the foreman says, I need these materials 3 days from now, enters it into the system, and those materials show up at his location or her location 3 days hence without any human intervention. Materials are found, materials are picked, materials are loaded, materials are transported to that location without any other people touching it, all automated. That's where we are. The technology exists today to do that. And I think it's just we just have this ginormous opportunity in the energy sector with these types of projects to harness the current, what's out there today, proven in other industries, and put it to work in ours.
Indeed. I mean, as you rightly said, the technology does exist today where we can, or project professionals can, develop optimized supply chain or optimized production system where those systems are self-optimizing because of the use of things like AI, ML, et cetera, et cetera.
And let me build on that. And then we've got AI monitoring stocks in the warehouse, and we've simplified our design so we have few standard materials. And it says, oh, gee, based on my analytics, I see we're running short 150-pound flanges. I'm going to order, and I know it takes this much of time to get them and to get them to this location, and it automatically reorders. And it goes back to the supplier again with no human intervention. This is all happening, machine talking to machine, ordering, delivering. All that could be automated with AI.
Very good. Well, panelists, thank you. But it seems we have few minutes left. Let me summarize what we heard at a high level. My personal two major takeaways are: project supply chains can and should be designed, modeled, optimized, and controlled to behave in a manner to meet project objectives. I think we all agree on that. And if you don't agree, raise your hand, please, or say something. The second takeaway for me personally, there are proven actions that can be put to work to reduce total cost, cycle time, and tying up of unnecessary and unproductive capital, which is extremely limited. And Gary mentioned a few examples. I would like to thank Gary, Phil, and Mark for a very good discussion. And on behalf of the Project Production Institute, we extend our thanks to all our participants from around the world. And if you are not already a member, please be sure to register so you can access papers on supply chain, on project delivery, on engineering, on construction, and how technology is improving project outcomes. Finally, we will be sending out a survey and link of this recording. We would appreciate your feedback as well as sharing the webinar with your colleagues, and we look forward to hearing from you. Thank you again, panelists, and thank you again, audiences around the globe. And we're going to give you at least, we have a few minutes left. We have 5 minutes left. So if anybody would like to answer one more question, ask one more question or two, please do, and I'll keep the line open. Are there any questions out there, or any of the panelists would like to shed some light before we have 4 minutes left? Panelists, anything on your end?
Yeah, I have one thing. A lot of people, Phil talked about the unknown unknowns, and I saw some questions about, well, how do we predict the next COVID-19? And the answer is, you don't. Black swans aren't predictable. When the author of the Black Swan, Nassim Taleb, was interviewed, he said, can you predict the next 9 black swans? And that's kind of an oxymoron, because by definition, a black swan is something that's not predictable. So we can't predict what the next thing's going to be, but we can make our supply chains more resilient by looking at various ways to buffer the variability and not just focus on 1 or 2 things. So I think that's an important takeaway.
No, indeed. I mean, variability is a fact of life, right? We are not going to be able to eliminate it, but there are ways that we can manage it.
Right. And unknowns will stay unknown.
I think, Mark, you raised a really good kind of summary point. And again, I come back to what Phil said, get your supply chain to behave like you own the whole thing, because you really do own the whole thing.
Right.
Relative to your project. And for me, the things that I'm going to do to cause that to happen, I'm going to make it as simple as I can, as short as I can, and build in the right amount of flexibility, because you can't, you're right, you can't anticipate a black swan. You can't scenario your way out of this. You've got to have characteristics of the system that deal with black swans better than one that doesn't.
Yeah, and you can't contract your way out of the risk. You can't contract away the risk.
You own all the risk. Yeah, you always own all the risk.
That's right.
No matter what the paper says.
Yeah. And I think another part of that, when, in the 70s and 80s, when lots of manufacturing companies, for example, made dramatic advances in supply chain, it was when they stopped thinking of supply chain as sort of the procurement operation that happened before the internal operations, and started thinking about it as no distinction between your suppliers, procuring items from your suppliers, your relationship with your suppliers, and your internal operations. Start thinking holistically about delivering, in that case, the entire manufactured product, and in this case, the entire project, right? Don't think of supply chain as something that another department does to meet some cost goals, but think about it as the integrated management of the entire delivery process. And I think that gets you a lot of the way there too.
That's exactly right, Phil. And because we are not doing that, project outcomes for the last 30, 40 years have not changed. If anything, they have deteriorated. So start thinking about the question that was posed earlier. What am I as a project professional gonna do differently to improve the outcome from the outcome of the project? Or what am I gonna do in addition to what am I doing today to improve project outcomes? That is critically important. So again, on behalf of Project Production Institute, I would like to thank all our participants and the panelists. This has been extremely productive, and we look forward to having the session in September and having a lot of participation from around the world. Thank you all very, very much for joining, and enjoy the rest of your day. Take care and goodbye.
Thank you, Paul.
Thank you.
Thank you.
Thank you.